All right, good afternoon and welcome to the webinar hosted by SEP Software. I'm Richard Yeager, Marketing Manager for SEP, and today I'm joined by Lanai Bain and James Delmonico of SEP, as well as John Hoffer with Red Hat Storage. Lanai is the VP of Business Development for SEP and is responsible for North American business development and channel partnerships. James Delmonico is our Senior Technical Support Manager and has been with SEP for several years. He knows his way around the software and can answer any in-depth technical questions you may have. And lastly, we have our Red Hat Storage guest speaker, John Hoffer. John has been around for more than 15 years and has had experience in storage administration and architecture experience. And we're happy to have him join us today and talk more about SEP's role in Red Hat Storage environments. Today we're going to give a brief overview as to what we do and then dive into a live demo of our software in the Red Hat environment. Feel free to ask any questions along the way. There will be a couple of Q&A sessions throughout the webinar, so please don't hesitate. And without further ado, let's kick off to Lanai and get started.
Hey, thanks, Richard. Appreciate it. Welcome, everybody. Thanks for joining us today. Appreciate your time. Just wanted to kind of start out and give a brief overview of SEP, kind of who we are as a company, what we do, what we focus on, and then, like Richard said, we'll break for a quick Q&A. So if you guys all look at your GoToMeeting console in the upper right-hand corner, there should be a little box there that says questions. Feel free throughout the presentation to type in any questions that you have, and like Richard had said, we'll have a quick break and we'll answer any questions. So SEP has been around for over 30 years as a production automation company and 20 years as a backup and disaster recovery software company. So we originated in Germany in the 90s, and basically the way our software came about, we were hired by some of our current customers at the time, Alcatel and IKEA, to write some custom code to back up some mission-critical data in some of their warehouses. And over time, we realized that it was very successful. It worked really well. It was very quick and efficient. So we decided to completely rewrite that code from the ground up and bring that to market. So that's actually been rewritten from the ground up several times since then. We have a pretty decent-sized presence in the EMEA market, and we're entered the U.S. market about 5 years ago, and we're growing very quickly here as well. So kind of overall points that we focus on as a company, there's three main points. And so the first one is to have one solution for an enterprise. And what we mean by that is we talk to a lot of folks, or we have talked to a lot of folks over the years, and we've really seen that people have a lot of different solutions in place to meet their needs if they have a large or heterogeneous or heterogeneous environment. And so what we really focus on is working with organizations that have, kind of broad needs as far as different platforms, different databases, different virtual technology, and we're able to work with those organizations and really consolidate their backups and disaster recovery solutions down into one easily managed central console. And so the way we're able to do that is just by supporting a very wide range of products. And we'll get into that a little bit further in the presentation. So the second main thing that we focus on is performance. The goal from the beginning for us was to figure out how to get data from point A to point B in the fastest and safest and most efficient way possible. And I think that we've done a very good job of achieving that. We use multi-streaming technology, and that's able to back up to 64 streams of data to a single tape drive, or an unlimited stream of data to a disk target. And so obviously that's going to reduce backup times and really give us pretty much the fastest performance on the market today. From a reliability standpoint, that was pretty much a cornerstone of our organization from the beginning. Being a German-based company meant that we had to meet some different requirements that would be necessary in the U.S. Because the laws are a little bit different in Germany. So as a backup company in Germany, if we tell another organization that we're going to be responsible for backing up their data, that means that we actually become financially responsible for all of their data. So we definitely don't take that lightly. And we've done a great job of having a product that's quick and efficient, but that is also reliable. So anytime you get a notification that a backup job was done successfully, you know that you can really go in and look at that task or, a group of tasks or, whatever the case may be, and be confident that all of your data is there 100% of the time. I remember when I first got into this industry, I was kind of surprised to hear people saying, I did a backup, it said it was successful, and I opened a file and there was nothing there. And obviously they were using another, other products. And to me that just seemed amazing. I couldn't believe that that actually happened. So again, one solution for the whole enterprise, very quick and efficient method of getting data from point A to point B or to multiple locations or to off-site locations, and also very reliable. And kind of as a fourth added bonus, it's not something that we really focus on or brag about, but it is something that's pretty important, I think. Our cost and the, ROI and TCO is very competitive. We normally come in at about 40% of industry average. So generally that makes it very easy for organizations to, have a very strong financial case as well to switch over to our solution. Getting a little bit more into the overall concept of one solution for an enterprise, we have here just a couple icons of some of the different operating systems, applications, databases, etc. that we support. We do support quite a wide range of things, so this is just kind of the most popular that we see on a day-to-day basis. But the list is pretty extensive above and beyond this. So starting on the left-hand side, you can see that you can run our main console on Linux, Windows, or Unix. So obviously benefit to Red Hat users is that we don't force you guys to go out and get an additional Windows license and put that on if you have strictly a Linux environment. While at the same time, if you guys already have a backup server that is running Windows and you did want to put it on there, you have the flexibility of doing that. You could also choose to put it on Solaris if you wanted. We pretty much just recommend administrators install our software on whatever platform that they're most comfortable with. So we try and be as flexible as possible, not only from the main backup administrator console, but also from a client or agent level as well. So support quite a wide range of operating systems there also, AIX, Mac, and many more. As far as applications go, everything we do is at an API level. So we always try and have native communication with any type of program or database or virtual technology that we're going to be working with. So, in the case of Microsoft Exchange, we have it's VSS aware, it's also DAG aware. We have single file, single email, and single user restore capability. Everything's backed up real time online. Same for GroupWise, same for Lotus Domino or Lotus Notes, and databases as well. Oracle, we communicate directly with RMAN, and etc. All the Microsoft products are VSS aware, SharePoint, MS SQL, etc. And then on the hypervisor side for the virtual technology, again, we communicate directly with the APIs. So for VMware, Hyper-V, and for Citrix, all you really need to do is authenticate to VMware's vSphere or Citrix ZenCenter. You don't have to actually install any software on those virtual platforms themselves at all. All you do is authenticate, and it will auto-populate a list of guests and all the guests that are listed under each host. So, and we'll get into that a little more as well. Okay, getting in a little more on the multi-streaming technology. Basically, there are other backup companies out there that say they do multi-streaming, and there are several that do. The difference, I think, is the level of performance that we see running our software in comparison to some of those other solutions. And so basically, we can break it down very granular. So we can have one stream of data coming from a single server, or it could be multiple streams coming from a single server, just depending on how the tasks are broken down. So really that gives us very fast performance. We have one customer who, in a single backup task, kicks off 1,100 servers at the same time. So they have 1,100 streams running simultaneous to a single group of targets. So again, very high performance. It's scalable to a pretty high level, and we're seeing great performance rates. A couple examples of what we've been talking about so far. Vodafone is a partner company with Verizon, and they are, I believe they're the largest cell phone company in Europe. They currently have us, they're currently using SEP for 1,500 remote sites, and I believe they're rolling SEP out to another 4,200 remote locations over this next year and a half. So again, just kind of goes to show the scalability and the fact that you can manage quite a few remote locations from a central console. Also, the Guardia Civil, they're kind of equivalent to the FBI and the State Patrol kind of put together and in Spain. And so we have, they use SEP for their entire enterprise at over 450 sites across Spain. Closer to home, U.S. National Archiving and Records Administration uses SEP for their enterprise email system. And with our multi-streaming technology, we were able to take their backups from over 6.5 days and bring that backup window down to 11 hours. I think the very first task that we set up and ran that was a full backup of everything, I think was about 13 hours. And then after we did a little modifying and some adjustments, we got down to about 11 hours. So again, pretty substantial reduction in backup windows because of the multi-streaming, because of the built-in integration with SEP, that it's able to go out and based on previous backups, it's able to tell which data is going to be what order it's going to be the quickest to back up which servers in what order. Another quick example, Port of San Diego, their backups went from over over 100 hours down to about 4 hours. So again, quite a reduction in time, and a little more specifically, they had a bunch of Oracle servers. I think they had about 13, 14, 15 Oracle servers that were previously taking almost 5 hours. I think it was about 4 hours and 45 minutes, and those backups went down to 42 minutes. So very effective on databases as well. A couple other features that we'll touch on real quick. We do have archiving capabilities that uses worm technology, and basically just a file archiving technology that's built directly into our console. Very easy to manage, very simple to set up, can be set up in 4 or 5 clicks. We also have deduplication built-in and replication as well. And one thing that I also like to touch on is the fact that we use all generic drivers. And what we mean by that is we don't have our own custom drivers that we write internally. We use just general operating system drivers. So what that means is any type of media or storage that's recognized by an operating system, we're able to back up to. So that gives our customers pretty much free reign on selecting any type of media that they want, whether it be something that's older that they haven't used for a while that they want to pull out of the closet and put back in production, up to the latest and greatest LTO device or a new SAN unit or anything. It really leaves all the options open, so people don't have to wait for us to come up with our own custom drivers, make sure there's no bugs in them, go through that process, certifications, all of that kind of stuff. So again, our whole goal is to be able to fit into any enterprise and offer as much flexibility as possible. We also offer bare metal recovery. We have bare metal recovery options for Linux, Windows, and also for Windows workstations. And basically it just captures the entire operating system, partitions, everything, and creates a bootable image file. And that bootable image file can be brought up on similar or dissimilar hardware, on physical or on a virtual machine. So it offers quite a bit of flexibility as well. Back to our virtual technology. Kind of already went over a brief introduction of that. Couple things I will mention, a couple cool features that we do have. If anyone is using Citrix XenServer, one of the cool features we have for that is we've solved the problem of activation loss. So if any of you guys have ever blown away a VM or had a VM go down and it was running Windows and you tried to restore it, you've probably had to enter in the product key code, the Windows authentication code. And so what we've done is kept the same UID and the same MAC address, so that anytime you bring back a machine, whether it's in the same Xen pool or a different pool, it really doesn't make a difference. It just comes right back up, it keeps all of the authentications, and you're just ready to go. So there's no downtime. You don't have to go hunt for licenses or anything like that. With VMware, one of our cool new features is if you back up virtual machines to a like an NFS share, for example, you actually don't have to wait to restore the VM like you normally would if you just have an image level backup. You can actually separate out the VMDK file and spin up that VM directly off of the copy of the backed up data, so you pretty much essentially have zero downtime. You don't have to, wait for an entire image to be restored back before you can spin it up and get it running again. Again, we talked about Hyper-V, fully VSS aware, and very similar functionalities to XenServer and VMware. We also have a solution for open source Xen as well. If anyone's interested in that, let us know and we can give you some more information on that as well. Okay, so that is a quick overview. Again, just wanted to kind of give you guys a brief overview. If there's any questions, if you guys can please submit those, and we will go ahead and start answering some of those. Give me 1 second here just so I can expand the questions box and see what you guys are putting in. So we do have a question, and it's asking about KVM support, so asking if we support KVM. And the answer is currently the KVM API is under development, so we don't really have the opportunity to support that yet. As soon as the API is finished and complete, then we will fully support KVM as well. So that's the answer. Yeah, we're basically just waiting for that API to be done so that we will support that as well. All right, any other questions coming in? Okay, I've got another question. It asks, are you guys able to, you mentioned, hold on, sorry. Are you guys able to back up to tape as well as disk? You mentioned both. And the answer is yes. We can back up directly to tape. We could back up to disk first. We can back up to disk and then have copies of that data replicated out to tape or to remote locations. There's quite a bit of flexibility. And one of the really cool things that is newer for us is the ability to back up to Red Hat storage as well, which John's going to be talking about shortly. And so we can actually set up Red Hat storage as a target for SEP and back up to Red Hat storage, which can then replicate that out to the cloud or different geographical locations, or really anything. So that's one of our really cool new features as well. Okay, any other questions? All right, looks like we are going to switch over to John now. John, I'm going to go ahead and make you the presenter and go ahead and turn it over to you.
All right, just a moment. Let me get my presentation going here. One moment, please.
And in the meantime, if anyone else has any questions, please feel free to put those into the questions box for John as well, and we'll have a little Q&A session right after his portion, and you guys can ask some questions about Red Hat storage, hopefully.
Yeah, happy to answer everyone's questions. Just got a few slides here as an introduction to Red Hat storage and our integration points and opportunities with SEP. So, Lanai, can you confirm that you're seeing my first slide?
Yep, looks good.
Great, okay. So we'll just jump right in here. Good afternoon or good morning, as the case may be. As Lanai said, my name's John Hoffer, Solution Architect with Red Hat specific for our storage offering, which it would not be at all surprising if you were to say that you had no idea that Red Hat had a storage offering, and that's okay. It's relatively new. About 1.5 years ago, Red Hat acquired Gluster and has turned that into a fully supportable, complete stack for software-defined storage. So Red Hat's not getting into the hardware business. We're still about software, but by doing storage as a software function, we're able to gain a lot of flexibility and a lot of new opportunities for how we scale, deploy, and manage storage, especially in the new IT model of virtualized and even cloud-based services. Certainly you could deploy Red Hat storage on the exact same hardware you would normally expect to deploy Red Hat Enterprise Linux, your typical x86 type of servers. But the great thing is that because we're software-defined storage, those servers then become a multi-petabyte scalable NAS type of namespace. So you're not limited to just the storage that you might have attached to or within a single server. Red Hat storage combines multiple servers into a scalable namespace. And those could be physical hardware. It could be virtual hardware as well, whether it's Red Hat Enterprise Virtualization, VMware, or other hypervisors. Red Hat storage can be deployed as a virtual machine and thereby freeing up and exposing capacity that might otherwise be trapped. Open it up to a scalable NAS type of namespace. And certainly, because it's, like I said, Red Hat Linux, it could be deployed in the cloud as well, and this is a real differentiator if you compare versus your typical enterprise storage solutions or typical enterprise NAS solutions. Software-defined storage can be deployed anywhere you need it to be, including the public cloud. Amazon is just one example of that. The scalable namespace would be accessed and consumed by your applications or other or users. One application example is SEP Sesam, of course. Accessed exactly the same whether it's deployed on-premise, virtually, or in the cloud. And the example that I gave earlier was perhaps you're doing local backups to Red Hat storage and you'd like to replicate that off-site, but maybe you don't even have your own physical site. You'd like to replicate that to the cloud for data protection, business continuity, recovery purposes. We can do that with Red Hat storage and not have any changes, not have to make any kind of changes to the application infrastructure to accomplish that. So Red Hat storage is designed for a variety of types of data. We're definitely going after where the growth is. Everyone is experiencing huge amounts of data storage capacity growth, but it's mostly around unstructured data. The problem of the good old relational database has kind of been solved in terms of how would you architect for performance and scalability and availability for a database, but it's the unstructured data that we see as causing our customers new and very interesting challenges now. It could be anything from just files and folders and content, just the generic stuff of the enterprise, all the way up to big data, map-reduced kinds of calculations, machine-generated data, the huge volumes of data that are coming out of our IT environments. We'd like to be able to get some intelligence and some value out of those. Storing that amount of information on a traditional enterprise storage system can be cost prohibitive. A new model is needed. And the kind of scale-out commodity software-defined storage that is Red Hat storage enables that. There's also a lot of growth around what you could call object data or long-tail data or archive data. In some cases, in fact, in many cases, this is the backups, the longer-term retention backups or just the cyclical backups that you're doing from perhaps SEP or other solutions. You're keeping them around a lot longer. The idea of overwriting backups when it's on disk often is starting to go out of favor a little bit. We need to keep more backups for audit purposes, compliance purposes, just being able to show the history of the organization. You got to keep it, but then the access pattern starts to tail off after a while, so that you get this idea of long tail or archive data. All of these count as unstructured data, and all of these are great use cases for Red Hat storage for a scale-out software-defined storage platform. And when we're putting these things together, what I want you to kind of think about, if you will, please, is as Lanai talked about, their ability to deploy flexibly, lots of parallel streams for high performance, many supported platforms. Consider how the scale-out storage capabilities on the Red Hat side are going to complement that and eliminate the bottlenecks, eliminate the limitations, eliminate the ceilings, as it were, of using perhaps traditional storage technologies. The way we build that all up starts with the basic concept of a server or a node. Could be physical, could be virtual, could be a cloud instance, but it's just another operating system, excuse me, another operating system instance where we're going to install Red Hat storage. Big surprise, Red Hat storage runs on top of Red Hat Enterprise Linux, so certainly any place you can deploy Linux, physical, virtual, or cloud, we can deploy Red Hat storage. Some amount of capacity would be presented to that node as usually a file system or some kind of disk device, for example. We'll call that a brick just because you build things with bricks. And we're going to build this abstracted or virtualized volume across those bricks. You can have 2 or 4 or 40 bricks in your volume, and it still looks like a single namespace to the storage consumers, backup applications, business applications, whatever the storage consumer might be. That volume still looks like a single instance, regardless of how many physical or virtual bricks we use to put it together. That's the power of the Gluster technology that's built into Red Hat storage, Gluster being the scale-out file distribution mechanism inside that's part of that Red Hat storage stack. So you start with your servers. Servers have capacities that are bricks. We build those up into volumes, and those volumes can be a target for a variety of things, such as disk-to-disk backups. Just to give you an example of some of the parallelism and the scale-out technologies that Red Hat storage has that you're able to exploit with a highly parallelized distributed application architecture, the simplest way we build one of those volumes is a distributed volume. And we're going to take the files, the content, and just as evenly as possible distribute those across the servers of the bricks that are in the volume. It still looks like a single namespace to the client or the storage consumer, but underneath the files are distributed across multiple bricks. Again, physical, virtual, or cloud. To the consumer, to the client, it all looks exactly the same. Another way to build a volume is a replica volume. The idea being we want to add some high availability to that volume namespace, and it kind of looks like what you see there. You're going to mirror or replicate the files from one brick to another. This is still local, kind kind of think a local LAN type of cluster for this particular namespace and volume, but we add high availability and some load balancing and performance to the volume by mirroring that data between two different bricks. File 1 and File 2 exist on both bricks, and to scale that out, we just combine those two volume types, distributing across replicated volumes so you get the high availability. Think of it like a mirror, right? And then you get the distribution to scale horizontally. Hundreds of terabytes, petabytes are not a big deal with Red Hat storage. If you're backing up your entire enterprise, as I said, a single solution for backup, the volume is going to grow, and much of that will be best served to be on disk for the near-term backups. This is the way you architect the disk solution, the disk storage behind that, to make it highly available, highly scalable, and still very parallel and high throughput without running into any bottlenecks. Remember, we're doing this as a scale out, so each of the servers that we add, 1, 2, 3, 4 here, for example, we can go up to 40, 50, 60 servers. No problem in a Red Hat storage environment. Each of those servers is adding network connectivity, CPU, memory, disk I/O, all of the capabilities each of those servers has is contributing to that overall namespace, providing that high throughput back end for the SEP parallel multi-stream backup process. Let's see, is this, oh, it is a build slide, sorry. So putting those two together, the broad cross-platform support of SEP Sesam with the scale-out capabilities and flexible deployment models of Red Hat storage, you've got the obvious use case of just enabling disk-to-disk backup without spending huge amounts of capital and time and effort and complexity in architecting either with an enterprise, traditional enterprise SAN or traditional enterprise filer. We're doing this with commodity hardware or virtual infrastructure and putting that namespace together for the disk-to-disk backup. But as I said, we can also include data replication as another feature built into Red Hat storage. One of the biggest and most cumbersome problems of any data protection strategy is the off-site factor. Great, I backed up my data. There's a lot of it. I need to get it somewhere else. In the past, we would take those tapes and make copies of them and put them on a truck, and the truck would go down the highway, and we'd hope that everything turned out okay on the other end. More and more, our customers are wanting to use their own network technologies and WAN and other sites and make that off-site backup at least be accessible, if not 100% active and live. So the geo-replication capabilities in Red Hat storage allow you to get that backup out of the building and to another location transparently, seamlessly, and it's almost fire and forget. Once it's set up, it's going to run in the background, and there's no need to worry about, excuse me, there's no need to worry about how am I going to accomplish the off-site component of my data protection strategy. It's all built into the two complementary technologies. So just to recap really quick on Red Hat storage, yes, it's software only. You might have heard the phrase software-defined storage from other vendors. This is really the next generation of open standards-based storage where we'll use your choice of hardware, but it's the software that builds up the capabilities that add value to the business. It is a modern architecture without any legacy ties to any kind of legacy storage architectures. It's completely new and completely modern. And absolutely, as I said, you've got your choice of deployment, physical hardware, virtual, cloud. It's very flexible. As you saw, we can add and remove capacity very elastically. If you need more capacity, just add more nodes. The namespace is always available and dynamically grows automatically. And the whole purpose is to really change the economics of the information access that we need to provide to our businesses. So that is what I have for slides. I want to open it up for questions and hand things back over to my friends from SEP to bring it all together.
Okay. Thank you very much, John. That was great. If anyone has any questions, please, again, go ahead and type those into the questions box, and I'll read those out, and we can answer those questions. And just to kind of recap, and kind of throw in our 2 cents, I think that one of the reasons we're really excited about working with Red Hat Storage is because of their flexibility. Just the fact that they can go in and work with any different type of hardware, for us, is great, because we have the exact same concept. We want to open up as much opportunity for people to design their infrastructure in the best way for them, and not have a bunch of different requirements that we need on our side, or try and dictate, what direction people go in the future. We try and leave that as open as possible. So I think, the whole Red Hat Storage product is excellent for that, and the two, working together, I think, really add value to any organization. Okay, looks like, John, it looks like you did an excellent job. I don't see any questions coming in. So you must have you preemptively answered everyone's questions. All right, I am going to go ahead and turn it over to James Delmonico. And James is one of our lead engineers, and he's going to go through and just kind of give an overview of SEP, what the GUI looks like, and some of the functionality, and so we can go ahead and get started on that. And James, looks like I can see your screen just fine, so I will go ahead and turn it over to you.
Okay. This is a fresh installation of sesam on Windows 2008. Everything that sesam supports is the exact same feature set on Red Hat Linux, and as well as Solaris. So everything you see here, even though this is a Windows machine, applies equivalently to Linux systems. Additionally, the storage requirements are such that we can use any operating system. So you can combine whatever operating systems you have to use the storage. In the special case with Red Hat Storage, we can have many nodes all writing to the same cluster volume. And for high-performance systems, that is great, because anywhere that Red Hat Storage is in use, any of those machines can write directly to that, even at the same time. We call that a data store, and that's just a path target for our system, and that mainly keeps the device from getting full. So it helps to manage expired data as well. For the client interface, we detect any type of running services. We use the GUI to actually choose those. So if we had SQL or anything like that, we would show that as available. With Red Hat, commonly we see OpenLDAP, Oracle, and all of that technology is supported as well. To help us leverage the multi-streaming, we use a group-based structure, so we can schedule against a policy. I've gone ahead and put in a couple groups just to show what we commonly use. With the hypervisor support, that's agentless support, and so we connect any member of the pool, and then we're able to see all the different virtual machines. And it doesn't matter if high availability is moving those around to different actual physical nodes. And so we just select an individual item to add the task, and once we've added the tasks, we put them in an appropriate group. To emulate what a schedule would do, a backup schedule, we'd do a full backup. In this case, we're doing it to our RHS drive group. And so sesam will start all of the different streams at the same time. Now that I've started this group, we have a few different tasks all running at the same time. And sesam is storage agnostic, so we can use any form of storage. Disk to disk to tape is all supported in any combination thereof. Here we can see some of our jobs are starting to go through here. As far as the supported operating systems, there's a list here. We support all the Windows-based operating systems, as well as VMS, NetWare, and all the Unix-based operating systems. There's also support for all the hypervisors that are commonly in use, ESX, Citrix Open Source Zen. We do support Mac OS, as well as some of the actual SAN technologies for doing SAN level snapshots like NetApp. As far as structure and reporting, SESAM is very easy to use. And so normally we do the schedule one time against the groups, and then after that, when we add jobs, we just add the jobs, put them in the appropriate group, and we don't really have to worry about scheduling or maintaining a lot of complexity. So it's kind of a set it and forget it approach. With storage targets, SESAM supports, of course, tape and disk, but with disk and Red Hat storage, we use these drives, and we're able to use groups to group those drives. And that'd be the same concept as having two drives in a tape loader, where we could just say, okay, use that group as a target. System will figure out the best tape drive to use and aggregate the jobs on its own. Same thing applies with Red Hat storage. We can have many different drives and different nodes here all attached, and those can write at the same time. So SESAM does open files, has Active Directory support included by default, as well as some of the other directory systems. And so you should be able to back up everything in your environment with Red Hat Server, Red Hat Storage, or any other combination of operating systems. That's the basis of the software. I think one of the real important benefits with SESAM is that there's native multi-streaming. And we're not kidding about native multi-streaming. That means 64 concurrent jobs per tape drive. That also means unlimited jobs to disk storage. Using Red Hat storage, we could have a dozen servers, some in the data center, some in cloud, some at other remote locations, all writing at the same time. Generally, that unties your hands as far as the storage goes and makes it so you don't really have to worry about scalability or anything like that. That's the primary functionality of the software. The other things to know are that almost everything is supported as far as different job types. If we look at some of the supported job types, you can see some of them listed here. So all the common email systems, we do single message restore, which makes those really easy. We do bare metal recovery for Red Hat and for the other Linuxes, and also for Windows. So once you make the bare metal backup, you know that will be restorable no matter what hardware or virtual machine you're on. And I think that can give you a lot more confidence as far as not worrying about going and digging up the same RAID controller as your original machine had or anything like that. All the databases are well supported. Our MySQL support also works with Maria, and so there are no concerns there. Some of the other things, SharePoint supported, VMware, we support both interfaces. For our system recovery backups, we take the registry, the system restore cabinets, as well as the Windows updates, so everything that Microsoft recommends. And that's fully supported for all the different operating systems. It also includes Active Directory by default. So that's really the basis of the software. I think under the hood, you have a lot of control as a user. The GUI is a standard SQL client, so you're able to see everything that's going on with the GUI and what queries it's making. Also, the system logs everything that it does on the back end. So you're able to see, tape removed, tape added, checking the size of the Red Hat storage, anything like that. And there we go. So now all of our backups have completed. This is actually an interesting demo because this firewall machine is actually the router for this Windows machine we're backing up. So it was able to, to do the hypervisor level snapshots, back up the whole virtual machine while we were actually using it. So you're able to do any of the hypervisor level backups whenever you want during daytime, during use, and not cause any service interruptions. At this point, I'd like to open it up for questions.
Awesome, James. That was great. We do have a couple questions in. So first question, do backups follow the traditional weekly full backups and daily incrementals? And that's really up to the user, the administrator. We can definitely set everything to be backed up, in a typical GFS rotation. That's fine. We have hundreds, thousands of customers with very varied needs. So some folks keep one copy of their data, and as soon as they have a new backup, that gets erased, and they keep one copy, and that's it. Other people, we have 40 different copies of the same data at 40 different locations. Some people have full dailies for a full year. So it really just depends on your needs and what SLA requirements are applicable, if any, and just kind of the way you'd like to see things structured. So as far as scheduling in our software, it's totally open, to schedule however an individual prefers. We definitely have some recommendations of ways that we schedule. Like James mentioned, one of the things that we like to do is to set up task groups. So that way, if you add a new server, you don't have to go in and set up a new schedule for that server or figure out when it needs to get backed up. All you do is drag and drop it into that task group, and it automatically sets the schedule, includes it in that backup task, and when that task starts, it just starts backing up all of those servers at the same time. So, you don't have to go in and figure out how long is this database going to take to back up, what's the priority level between, this and all the other ones, and what order should I put everything in, and how long are they all going to take, and what media are they going to. And especially with the Red Hat storage option, you can just select one target, and you can have all of the jobs kick off at the exact same time. So, I mean, really, it doesn't get a whole lot easier than that. Okay, other questions? Okay, can SEP back up to multiple locations using Red Hat storage at the same time? And James, I'll turn that over to you, but I believe, yeah, that's not a problem. We can have the different streams going to different locations all at the same time, correct?
Correct. And actually, Sesam is a server-to-server architecture, which means that all of the different backup jobs stream directly from the client to the target storage. With Red Hat storage, that could be on the local machine or it could be remote. Any combination is supported, and the data does not have to go through the backup server necessarily. So really, it's just a direct stream from the client to the storage you choose.
Okay, great. Okay, any other questions, either on SEP or on Red Hat storage? Give you guys a second to put in any additional questions. All right. Well, it looks like we have answered everybody's questions. So we will also be doing another webinar, which I think Richard will give a little more information about. And also, one thing that we invite you guys to do is, if you do have any individual questions that are kind of based on your infrastructure or your environment, if you'd like to see any more, information, or maybe even set up a proof of concept of your own in your own environment, that's something we would invite you to contact us, and we'd be happy to answer any questions. Or if you would like to have things set up in your own environment, then we're more than happy to kind of help get through that process, walk you through the process. Again, it's a very quick process. The entire SEP program is 54 megabytes, so it installs in minutes. We can have it up and running in 20, 30 minutes with jobs configured and backups started. So it's not a very long or drawn-out process, just to throw it in a test VM and play with it a little bit to see how it works. So please shoot us an email or give us a call. Also, please feel free to reach out to John Hoffer with any questions on Red Hat storage, and any questions that come into us, we will also coordinate with him as well, and make sure that we get all the questions and interest answered. So, from all of us, thank you for joining, and I will turn it over to Richard to sign us off.
All
right, yeah, thank you everyone for joining, and also a big thanks to John for being our Red Hat Storage guest speaker. And like when I said, we are going to be doing another Red Hat Storage themed webinar here in a couple of weeks, so be on the lookout for an invite to that. Again, yeah, thanks to everyone who attended, and we'll see you on the next one.